Hi everyone, welcome back to our channel. Today we are going to solve the theoretical calculation for the given T network, and we are going to verify the mesh analysis as well as the nodal analysis. Okay, so in order to perform these two verification, let us try to analyze the network. An AC source is there and T type of network is there, but the type of inductor is 50 millihenry. Okay, so now let us try to solve. Okay, so initially let's try to mark there are this node as an unknown node as Vx. Why? Because the voltage at this point is 20 is known, the voltage at this point is not required. If you find the voltage at this point, then you can find the current in 47 ohm branch. I am marking this current as a current I1. I am marking this current as current I2 and this current as I3. So when you apply the nodal analysis here, all these currents has to be zero. That's how we can verify the nodal analysis. Okay, now let us try to solve the problem. Okay, see here. So in order to verify nodal analysis, let us try to apply the Kirchhoff's current law. Okay, so try to apply the KCL. You can see here there is no entering current to this node, all the currents are leaving. Okay, so whenever all the currents are leaving as per the Kirchhoff's current law, entering currents is equal to 0, the leaving currents are I1 plus I2 plus I3. Okay, so therefore 0 is equal to I1. How to write down I1? So the current I1 is flowing in this direction. Okay, so the current I1 is flowing from high potential to low potential. So high potential is how much? This is plus, this is minus. So I can write down, therefore I can write down the formula V by R. Okay, so therefore how to write down the current which flows in this branch is, so the voltage at this point is Vx. Next one, what is the voltage drop? So this is AC supply should not mark terminal. For your analysis I am marking this is minus high potential minus low potential. So Vx minus 20 divided by R. What is the resistance of the branch? 47 plus. How to write down the current which flows in this branch? Okay, so the current which flows in this branch, I am writing it as high potential minus low potential by R, which is nothing but V by R. So high potential is how much? Vx minus 0 divided by 2000 plus. So how to write down the current which flows in this branch? Okay, so how to write down is Vx minus 0. Okay, so Vx minus 0 divided by R. So R is nothing but 100 plus, so this is 500 plus 500 plus, so this also I want to express in terms of Excel, I mean in terms of ohms. This can be written as plus J X L ohms. Okay, so this I can write down it as, so J just you write down XL ohms. XL is nothing but omega L ohms. So what is the value of omega? 2 pi F. F is how much? As per the given problem, 2 pi into 50 into L. L is how much? 50 milli Henry. Just use your calculator, then you are going to get as plus J 15.7 ohms. Okay, so these three elements are in series. So since directly they are in resistance, I have written in 500 plus 500. This is J 15.7 ohms. Just add plus J 15.7 ohms. Okay, now our target is to find out voltage Vx here. Okay, how to find out Vx is remove the terms to this side, so which is 20 by 47 and take Vx as an common term. So when you take Vx as a common term, then you are going to get 1 by 47 plus 1 by 2000 plus 1 by 1000 plus J 15.7. Okay, use your calculators and convert this A plus IB form into an R comma theta. Therefore you are going to get 20 by 47 is 0.4 25 is equal to Vx. So if you perform all this in the polar form, then you are going to get 9.9 into 10 to the power minus 4 at an angle of minus 0.899. So this 1 by 2000 also you add it, and 1 by 47 also do it, then you are going to get the value of Vx as 18.66 at an angle of 0.039 volts. Okay, so this is the voltage we are getting at this point. So this is the voltage is approximately 18.66 volts. Okay, now let us try to apply this in this equation. Okay, so now when I'm trying to apply this equation, the value of Vx is how much? 18 point. So this is 18.66 minus 20 divided, I mean 0 is equal to divided by 47. So this is 18.66 divided by 2000 plus 18.66 divided by 1000 plus j 15.7. Okay, so when you do it and convert it into an required milliamperes, therefore 0 is equal to, you're going to get here as minus 0.0285 plus here you are going to get as 9.33 milliamperes, and here you are going to get it as 18.65 milliampere. Okay, so this is in minus, just multiply this value also with 1000 and divide with 1000. This 1000 will come up, which will be in milliamperes, and when you multiply 3 zeros, 1 2 3, so this is 1 2 3, which is nothing but minus 28.5 milliampere plus 9.33 milliampere plus 18.65 milliampere. Here itself you can see here 18 plus 9 is approximately 27. 27 plus 6 plus 3 is also. So this is minus 28.5 milliampere. This is plus 28.5 milliampere. I mean 0.5 milliampere. Both will nullify, which is equal to 0 amperes. So at the left hand side we have 0 amperes. At right hand side also we have 0 amperes. Then I can say we have been verified Kirchhoff's current law. Indirectly, we have been verified the nodal analysis. So successfully, we have been verified the nodal analysis. Now, so after verification of the nodal analysis, now let us try to do the mesh analysis. Okay, mesh is very simple. So just take the original circuit. So let us see here how to apply it. So let us try to redraw it. So here you are going to have an AC source, so here you are going to have an AC source and a resistor of 47 ohm and a one more resistor and a one more resistor with an inductor. Okay, so we have been find the current which flows in this branch, so which is nothing but what is the amount of current is minus 28.5 milliampere. The current in this branch is 9.33 milliamperes. The current which flows in this branch is 18.65 milliampere. Okay, so we need to find out, this is 47 ohms, this is 2000 ohm, this is 500 ohm, this is also 500 ohm, and this is plus j 15.7 ohm. Okay, now let's try to verify. So now we are going to verify the mesh analysis. So how to verify the mesh analysis is directly by applying Kirchhoff's voltage law. So see here, so here we have 20 volts, which is nothing but an AC source. So just for your analysis, let's try to find out the voltage at this point. Okay, so voltage at 47 ohm is equal to 47 V equal to I into R. Okay, so this is nothing but R is 47 multiplied with minus 25.8 milliampere. Then you are going to get this. Since the current is flowing like this is positive terminal, negative terminal, this is positive terminal, this is negative terminal, this is positive, negative, positive, negative, positive, negative. So here when you multiply this 47 into 28.5, then you are going to get as minus 1.3395 volts. Okay, and similarly find the voltage at 2000 ohm resistor I into R. I is how much? 9.33 milliampere multiplied with 2000. So 1000 and this will get nullified, and multiplied with 2, you are going to get 18.66 volts. And we need to find out the voltage at this 500 ohm resistor. Voltage at this 500 ohm resistor is equal to I into R. So I you are going to get as 18.65 milliampere multiplied with 500. So therefore when you multiply this with 500, you are going to get as 9.325 volts. Okay, so this is 9.3, here also same value, therefore here the drop is 9.325 volts. Okay, and again voltage across 15.7 ohm resistor. Okay, it is nothing but an inductor, which is nothing but the current is 18.65 milliampere multiplied with j 15.7 ohm. Therefore you are going to get 0.3 volts as the drop. So now let us try to redraw it with respect to the voltages. Okay, same network you are going to get. So this is resistor 1, resistor 2, and this is the another resistor, and this is the another resistor, this is the another inductor. So how much voltage we applied is 20 volts. Okay, so now let's try to draw its polarities. So here you are going to get plus, minus, this is a 47 ohm resistor. So here you are going to get an drop of minus 1.335 volts, and this is positive, negative, and this is a 2000 ohm resistor, and here you are going to get 18.66 volts. The voltage at this point is 18.66 volts, and at this 500 ohm resistor the current is flowing. Here you are going to get a drop of 9.32 volts. Here also you are going to get 9.32 volts, and here 15.7 we are going to get a drop of 0.3 volts. So now we need to verify this mesh analysis. We are going to verify it by applying Kirchhoff's voltage law. So current is leaving. What is the leaving polarity of the voltage? Which is nothing but plus 20. So current is leaving. So all the polarities are marked. Okay, leaving terminal is plus. Okay, and what is the voltage drop? Minus 1.335 volts. Okay, and current is leaving. What is the leaving terminal of this voltage? Minus 18.66. Okay, so 18 plus 19 plus this decibel, which is nothing but plus 20 minus 20, therefore both are equal. Automatically what is verified is Kirchhoff's voltage law is verified for first loop. And coming to this loop, okay, so current is leaving, what is the leaving, what is the voltage at this point is 18, okay, so voltage source is 18.66 volts drops, okay, so minus, so current is leaving, what is the leaving terminal, here we have minus 9.32 volts, current is leaving, what is the leaving terminal, we have minus 9.32 volts, current is leaving, what is the leaving terminal, we have minus 0.3 volts is equal to 0. This minus indicates these are voltage drops, and here this is nothing but the total voltage or the source voltage. So when you add 9.3 plus 9.3 plus 0.3, which is also approximately equal to 18.66 volts minus 18.6 volt, that equal to 0. So 18.66 is equal to 18.6. So voltage sources is equal to voltage drop. Automatically same KVL is verified. So KVL is verified means what is verified? Mesh analysis is verified. So this is how we are going to verify KCL as well as the KVL. Okay. So here we have taken the currents and all the currents we added, and we concluded that the currents are entering and leaving are same where KCL is verified. Similarly, by finding all the voltages we obtained, so 20 minus 1.3 you are going to get 18. This is the drop created by this 47 ohm, and resultantly 18.66 is available. This 18.66 is divided as 9.3, 9.3 and 1.3. Therefore total voltage is divided, automatically KVL is also verified. So this is how to verify KCL as well as KVL. So if you feel my explanation is good, please give an like to the video, and please share with your friends those who are studying the same subject. And if you have any doubts, let me know in the comment section. I will answer all your doubts. If you are watching the channel for the first time, subscribe to my channel with the name KV Thulasi Ram. So kindly support this sort of channels, because these are free channels for the development of students and faculty. Thank you for